Now let's get into application of all that we have studied about endothermic and exothermic reaction. First of all, that thing that we have got to keep in mind is whenever we need to supply energy to the process for its feasibility, then the process is endothermic. That is, del H is positive. Alright, so let's take first example. Now in case of enthalpy of fusion, think of ice getting converted to water. We have got to supply heat. So del H is fusion of del H is positive. Let's get into the second one, enthalpy of vaporization. Enthalpy of vaporization also, for water to get converted into steam, we have got to provide heat. So del H positive. In case of enthalpy of sublimation, sublimation is actually two processes. It is firstly solid to liquid and liquid to gaseous. So these phases are there. So in any case, when it moves from solid to liquid, it requires heat, and liquid to vapor, that also requires heat. So del sub is also positive. Then in case of enthalpy of ionization, when we talk in terms of enthalpy of ionization, it is stripping of electron. Now suppose you have metal gaseous state. So in order to ionize it, you have got to strip electron. So we know there's something called as ionization potential. So energy required for stripping electron from metal also is positive because energy is required. Del H is positive. Atomization. Now suppose you have gas X2 gas. You want to convert Cl2 chlorine gas into chlorine atom, for example. There also you require energy. So yes, you have to supply energy. So del H gets positive here also. Now when we talk in terms of enthalpy of solution, a bit complicated process. So now in case of enthalpy of solution, I already explained you, this 0 is standard enthalpy of solution. Now there are two processes occurring here. As we saw in case of sublimation, two processes are occurring. That is, one is getting solid to liquid and liquid to gaseous state, solid to liquid state, liquid to gaseous state. Whereas here it is first is the lattice energy. Now imagine sodium chloride crystal, putting it in water. What happens? The shape of crystal is dissolved, and at the same time it also gets converted into ionic format. Alright, so that's the first process. And the second process that occurs is hydration. Alright, so MX crystal put in water, and whenever we are talking in terms of thermochemistry, we are talking in terms of gaseous state. Alright, so metal gaseous and anion also gaseous. Alright, cation, anion both in gaseous state. So this is what is the first process. Now that is what is del L H. Why L L? That is because of lattice energy. Energy required to separate 1 mole of solid ionic compound into gaseous constituent ions. And del H is always positive. So lattice energy is always positive. Keep that in mind. Okay. Alright, now let's proceed ahead. Let's try and understand hydration, enthalpy of hydration. So water molecules surrounding ion, that's what is hydration. Now already we have M in gaseous state positive, X gaseous state negative, cation, anion, X molecules of water surrounds it, Y molecule of water surrounds this. How does it surround? Now in case of water, we know H2O. So O is more electronegative than hydrogen. So delta negative we have here and delta positive towards hydrogen. Delta positive towards hydrogen. So all delta negative, delta negative, delta negative, delta negative of water would be facing the cation. Alright. Now water normally we represent it as cashew, because we know that the bond angle of water, which I have already presented earlier in my video, is 104 degree. Alright, so it appears like cashew. Alright, so that is what happens in case of cation, whereas in case of anion it's the reverse way. Why? Because this is negatively charged, anion negatively charged, H, delta positive, delta, so all positive facing towards the anion. So this is how hydration occurs in case of cation and in case of anion. Alright, now another important aspect is del hydration enthalpy is always negative. Now if we are taking example of sodium chloride, in case of solution we would have two enthalpies. One is that of lattice and another is of hydration. Now in case of sodium chloride, lattice energy is plus 790, whereas hydration is, enthalpy of hydration is minus 786 kJ per mole, kilojoules per mole. When we subtract, what we end up with is positive 4 kilojoule per mole. So here again, if we come to enthalpy of solution, so what we find is it comes to positive as the net result of two enthalpies, lattice and hydration. Alright, let's also check out electron gain enthalpy. Now till now what we saw were all del H were positive, whereas in case of electron gain enthalpy it is negative. Can you guess why? Now chlorine is one of the best example. Now Cl in its valence shell has 7 electrons. Now it is highly electronegative, so it pulls one electron. It needs one electron to complete its octet, and it does so. Alright, from alkali metal, alkaline earth metal, or it does so. Now while doing so, what happens is already there is intra-electronic repulsion in the orbit. So owing to which, to accommodate one more electron, it has to shelve out energy. So it has to give out energy instead of taking energy, and that's the reason why it is negative. Alright, so electron gain enthalpy is negative owing to the reason that I explained. Understand these enthalpy situation well, revise it, understand it, and apply it for your reactions. So I hope it was all very clear, helpful for you all. See the video 2-3 times and try and understand and apply. You would definitely find it supportive towards your NEET and JEE and other competitive exams. Alright, all the best.